ask some of the questions that you might have for me. Theo, please confirm if you are able to see the screen that I'm sharing. Theo, are you there? Can you please help? Are you
Sorry, you're muted.
Sorry, I'm talking on mute here. I was asking, are you able to see the screen that I'm sharing?
Yes, I am.
Okay, all right. Thank you so much. Then we can get started. Okay. All right. So if you've just joined us, welcome, guys. We're going to be looking at some functions today. And let's just dive right into doing the functions problems. Okay. Remember, if you have any questions, please do post in the chat or raise your hand so that we can see how we can help you out with some of the questions that you might have there. Okay. So, okay, so let's look at this question here. I'm hoping you guys can see on your devices there. It's question 5. It says, sketched below are the graphs of f of x is equal to ax squared plus bx plus c, and g of x equals to minus x plus 5. So immediately we know we're dealing with a parabola and a straight line. And furthermore, they're saying a and b are the x-intercepts of f. T, which has coordinates 3/2 and 49/4, is the turning point of f. Furthermore, B and S are the points of intersection of F and G. Okay. Now, let's look at the very first question. Calculate the coordinates of B. Okay. Now, let's see what we can do. That'll be the easiest question there, because we know that the coordinates of B, for us to find that, we can use the straight line. Okay. And what is happening at B? That is the x-intercept. So simply, it will say 0 is equal to minus x plus 5. And we know that x is equal to positive 5, meaning that B has coordinates 5 and 0. As simple as that. Okay, next question. Determine the equation of f in the form y is equal to a x squared, in that form. So the standard form, x squared plus bx plus c. Okay, that shouldn't be a problem at all, because we know we have the turning point. Let me just scroll back up. We have the turning point. We don't only have the turning point, but we also have the point that we found in B. Okay, so that should make our life a little bit easy. So let's see what we can do there. Now, I'm going to use the form y is equal to a into x minus p all squared plus q. Remember, this is the turning point form, and I'm sure you guys have seen it before. Why am I using this form? Because I have p and I have q, because they gave me the turning point of the function. Okay? Now, let us start substituting there. So, I'm going to say I have y is equal to a into x. Now, let me go back. I can't remember my turning point. It's 3/2 and 49/4. So it's going to be minus 3/2 all squared plus 49 over 4. Okay, guys, please remember to mute yourself so it doesn't cause distraction. Okay. Perfect. Now, what else can we substitute? We can substitute the other point that we have. Sub B, which has coordinates 5 and 0. So this will be 0 is equal to A into 5 minus 3 over 2 all squared plus 49 over 4. Okay. Now all we need to do is calculator work so that we can find our A value. Can quickly do that. So if I say 5 minus the 3 over 2, then I square that, I'm going to have 49 over 4. Then I can, because it's the same thing, then I can tell you what my A is. My A is simply going to be minus 1 because I've divided both sides by 49 over 4. And I have 49 over 4 for that one as well. Okay. Now that I have that, I'm almost done. So y is equal to minus 1 into x minus 3 over 2 all squared. Right. Now, instead of saying all squared, I'm going to just write 2 brackets. And then plus 49 over 4. Then this is simply going to be y is equal to minus 1 x squared minus 3x. Then this is going to be plus 9 over 4. Then plus 49 over 4. Then y is equal to minus x squared plus 3x plus 10. And we have it in the form ax squared plus bx plus c. Okay, wasn't too bad. Now, 5.3. If f of x is equal to minus x squared plus x plus 10, which is what we found, that means you're on the right track. Calculate the coordinates of x. So I'm just going to go back to try and locate s. Okay, so s is the point of intersection of the two graphs, which is quite easy for us because we know whenever we have two graphs intersecting each other, their point of contact is, we equate them to find their point of contact. Okay, and let's try to investigate why do we do that. The reason we do that is, let's consider the straight line, the y value of the straight line at that point, right? And the y value, so I'll just say y of straight line, and then on the right, I'll say y of the parabola. Those two things are equal. So the y of the straight line is equal to the y of the parabola. Okay. Right. In other words, the functions themselves. That's why we can literally say f of x is equal to g of x. That's where it's coming from. Okay. Now, let's just equate those. So I can say f of x is equal to g of x. Then my f of x is minus x squared plus 3x plus 10. Then what was my g of x? My g of x was minus x plus 5. Okay, now it's just a matter of solving this. Minus x squared, then plus 4x minus 5 is equal to 0, or just x squared minus 4x plus 5 is equal to 0. Okay, I'm hoping I am on the right track. Yes, I'm not making any mistakes. So if I am, please do stop me. Minus. So 5 came over, became minus, divided everything. Okay. Now, let's just solve this. Okay, we're going to have x and x.
Sorry about that. Can you hear me?
Yes, I can hear you.
Please just zoom in a little bit because you got a lot of white space on the side. Just
Okay.
so at least the work is filling out the space you're working on. Like 170, 175, 180, somewhere there.
Is better or more? Okay. 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 So as I was saying there, that now we just need to factorize this. Just double checking. So minus x squared is just minus x squared. And I brought this, it became plus 4x. With the 5, it was plus 5 here. This is a plus 5 because I took this to that side. It became 10 minus 5. So it should be a positive 5. Now this should change to a minus, just like that. Okay, now let me try to factorize that. So here I know I'm going to have minus 5 and a positive 1. So that x is equal to 5 or x equals to minus 1. Now, we're looking for s. Let's check where s is. It's in the second quadrant where our y is positive and our x is going to be negative. Okay, so it means that s is going to take this value here and not the 5. Now, I'm going to substitute this into the straight line. So y is equal to minus 1 plus 5, which means that y is 6. So s has coordinates minus 1 and 6. Okay? Now, interesting question. Use the graphs to solve for x where f of x is greater or equal to g of x. Okay, f of x is greater or equal to g of x. Okay, let's go back to our graph thing. Let me just write it here. F of x is greater or equal to g of x. Okay, now this is an analysis question, right? Don't try to solve it using inequalities, right? It doesn't always work out. And the easiest thing for you to do is to look at the graphs and then check. So where it says f of x is greater than g of x, it simply means where f of x is on top of g of x, where f of x or where the parabola is on top of the straight line. Okay, now I'm just going to try and highlight that region. Can we all see that the parabola is on top in this region? Okay, now everything else, for every other region, the parabola is under. Because if you can check, the straight line is on top here and the parabola is under it. It's clear, right? Now even here, the straight line is on top and the parabola is under it. So the only region is the highlighted one, which is f of x is greater than g of x. Now, how do we then represent that region? Okay, so we know it's from this point here all the way until point B. Okay, what were the coordinates of S? Remember we said S has coordinates minus 1 and 6. I think that's what we got. That was the previous question. Then furthermore, we found B to have coordinates 5 and 0. Now that section there where f of x is on top is going to be, and remember, let's go back to our question. They were asking for the values of x. So that answer will be minus 1. X is between minus 1 and 5, but inclusive of both. Why is it including? They said greater or equal. Let me go back to the graph and show you. So at this point, because they are equal to each other, and at that point they are equal to each other. And the question did say equal. That's why we are including the both sides, both of the sides rather. Okay. And carry on. Now let's check. So the next question says,
The question there.
Is there a question?
Yeah,
Okay.
someone wants me to repeat one. I'm just speaking as well.
So please repeat 1.4. Okay, I can quickly just repeat.
Sabah,
I can hear you, Ernest.
okay, cool. Sorry, just very, very important also with 5.4, that they must either do set builder notation or interval notation. So it's important that if you're doing set builder notation like that, you must specify the type of number, that X is an element of the real numbers for it to be a complete answer.
Okay, so you can then say X is an element of reals like that.
Yeah.
For this type of notation.
If you're doing set builder notation. If not set builder notation, if you're doing interval notation, then interval notation is implied that it's for real numbers. You don't have to specify it.
So for interval notation, it would be X is an element of -1 all the way until 5 inclusive. So either or is fine.
100%, yeah.
All right. Thank you, Ernest. Okay, and then there were people asking me to repeat, but Edio said repeat 1.4. I don't know if Edio meant 4.1, so I did not do a 1.4.
Maybe they meant 5.4.
Okay. Okay. You're saying 5.4. Okay, no problem. I'm going to just, quickly just explain 5.4. So the question says f of x is greater or equal to g of x, right? So remember, because we're dealing with inequalities, think of the crocodile mouth. This inequality sign is the crocodile mouth. What is it eating? The crocodile mouth wants to eat g of x, meaning that, it wants to eat f of x, sorry. Let me correct myself. The crocodile mouth wants to eat f of x because that's where it's open towards, meaning that f of x is the one that is greater than g of x. In other words, f of x is on top of g of x. Now, what we're going to try and do is check our graphs, right? Where is f of x on top of g of x, right? And what we're going to do is we're simply going to highlight that region. Right. So the highlighted region shows you that f of x is on top, because if you can check under it, you will see the straight line under it. Okay. Now, if you looked at any other region, so let's look at this region here, and let's look at that region here. So let's start here on the left-hand side. Just let's start on 1. The straight line is on top, and f of x is under it. So we don't care about that region. Then the region 2, the region labeled 2, the straight line is on top and the parabola is under it. So we don't care about that region. That's not what the question is saying. We want where the graph or the graph of f is on top. And it is this region here. Because as you can see, it's on top, and under it you will find the straight line. Okay. Now all we have to do, because we found our region, we then have to write in a mathematical expression to show what region that is. Okay, and where does it start? Remember they said what? The values of x. Where does it start? It starts here. What is that x value? That x value is, we got it to be -1. Forgot number. Yeah, I think that was -1. And then this one was 5. Okay, now f of x will be on top in this interval between -1 and 5, only there. Okay, now how do we represent that? We will simply say x lies between -1 and 5, right? But both of them are included, meaning that you need to attach that minus if you are using this notation here, right? And then say x is an element of real numbers. If you're using another notation, you can simply say x is an element of the hard bracket now, not the soft bracket, because the soft bracket doesn't include. So you use the hard bracket to say -1 to 5. Yeah, hoping that makes sense. And then Tabella asked me to repeat 5.3. Okay, I'll quickly just go over 5.3. So 5.3 was saying, if f of x is equal to minus x squared plus 3x plus 10, calculate the coordinates of s, right? So here they just gave us the function f of x, right? In case we got a different one in the previous question, remember the previous question, we found f of x. If you got a different answer, then you're going to use the one that they're giving you now because they're saying that f of x is this. Calculate the coordinates of s. What is happening at s? That's very important. We can clearly see that if at point s, the two graphs are equal to each other. They are intersecting each other, right? Only at point A state, that's when they're equal. Also, another point would be B. Okay. Now, how do we find these coordinates? We equate the two graphs together. Right? So I was just explaining using this part here. So to say y, the y value of s, right? So the y value here, if we considered the graph of the parabola, so the y of the parabola and the y of the straight line. So y value, yp, just stands for the y value of the parabola. And the y value of the straight line at point is, those two things are equal to each other. And remember, f of x and g of x, those two things are telling us about the y values. That is why we can equate the graphs together. Because what is the y value of the straight line? How do we find it? We'll simply say minus x plus 5. Then what is the y value of the parabola, right? The general one. That will simply be the graph that they gave us, which was minus x squared plus 3x, and what else? Plus 10. So we can equate those two in order for us to find what the x value is. And that's exactly what I did. So I simply said f of x is equal to g of x, then I equated them. Okay. Bring this x to the right-hand side, the left-hand side. 3 plus 1, that gives you 4. 10 minus 5, that gives you a positive 5. Then I just divided throughout by minus, so that I have x squared minus 4x minus 5. Then from there, I factorized. Okay, then I had two x answers. But because we were looking for s, we need to check where s is. S is in the second quadrant. What do we know about the second quadrant? The x values are negative, which means that s must assume the negative value that we found, which is minus 1. Then we take that minus 1, we substitute it into any of the two graphs. I always go for the easy way out. The easy way out in this case would be the straight line. Even if you substitute it into the parabola, you're going to get the same answer. Since the straight line is quick and simple to substitute into and get a corresponding y value. Okay. Perfect. Moving on. So now 5.4.2. We minus x squared plus 3x minus 2.25 is less than 0. Okay. Now, let's see how we can go about this. Okay. So what I want to do here is I'm going to try and break this down. Another important thing, right? Please do not multiply. Do not say this is minus 2 over 4. This is a very common mistake, right? This is a mixed fraction. On your calculator, there is a mixed fraction button where you press the shift and you press the fraction button. You don't press a minus 2 and then a simple fraction. Otherwise, the calculator is going to multiply the 2 with the 1. Then it's going to give you an incorrect thing. I'm hoping we're all together there. You don't say 2, then fraction. You press shift, press the fraction button, then you'll set the 2. Okay, now everyone is with me there. Let's see how we can go about this one. What I'm going to try and do here is I'm going to say I have minus x squared plus 3x. Okay, then I'm going to take this to the right hand side. So I'm going to say I have 2.25. Okay, Now, what I'm going to do is I'm going to try and be somewhat smart, right? This reminds me of a graph that we dealt with. So what I'm going to do is I'm going to say plus 10 here, right? But because I've added a 10, this was nothing. I need to add it on the right-hand side as well. Whatever you do on the left, you need to do on the right. Okay, this way I haven't really done anything because if I bring this over to the left-hand side, it subtracts. Okay, so this is very important. Okay, now, what do you remember? Okay, I think Mohotlo has a hand. Mohotlo, you can unmute and ask your
Why are we
question.
adding
Okay, so the reason we're adding that 10, right, is to try and make life easy for ourselves, right? So I didn't just think about the 10. I was like, this makes sense to me. I remember seeing this somewhere. Then I'm gonna scroll up, right? I'm pretty sure you remember this. Minus x squared plus 3x. You remember that it's a graph that we've been dealing with. Okay, that's where the 10 is coming from. You see this? So I was like, I'm going to add this 10 because I remember seeing it in the function that we were dealing with, right? But because I've changed it, because I've added a 10 to make it a function that I was dealing with, I need to add it on both sides. Okay, the reason for that is now this becomes a function. What function? F of x. Okay, that's what they told us as well. They said that f of x is minus x squared plus 3x plus 10. Now this whole guy becomes f of x is what? Is less than. Now I just add that. Okay, and 2 1/4, a quarter is 0.25. So this is 2.25 plus 10. Then f of x is going to be less than 12.25. Are we all together there? There are no questions. I'm thinking that everybody's fine. Okay, just going to go back to our graph and see if what we are saying makes sense. So we said that if x is less than 12.25, just going to go back to our graph. So f of x is less than 12, okay. Now, what do we know about 12.25, right? So remember that this answer here, that is the 12.25. So if you say 49 divided by 4, that gives you 12.25. We're not done answering our question. They want the values of x, where f of x is less than 12.25. Okay. Now let's give them that. So we're going to simply say that x is an element of real numbers, but x cannot be equal to 1.5. Where did I get this 1.5? This 1.5 is the 3/2. Okay, I'm going to go back up so that you can visualize what I'm saying. We want the x values where our graph is smaller than 49/4, right? In other words, 49/4 is 12.5. We want all the x values where our graph is smaller than that. And because there's no equal sign, we can't include the 49/4 or the 12.5. Right? Which region is that? Everything excluding that dot, that turning point. That's where our graph is under 12.25. Now, what is that region? Right? So somebody could have said, x is less than 3/2, or x is greater than 3/2. But I just wanted to say x is an element of real numbers. So for every real number that you can think of that x is assuming, our graph will always be smaller than 12.25, except at 3/2. Because what is it at 3/2? At 3/2, our y value is 12.25, and that's not what we want. As per the question, right, we must be smaller there. Okay, hoping that made sense. Okay. Then we're going to carry on. Let's look at this new graph. The graph of f of x is equal to log base 4/3. X is drawn below. Okay, so it's a log graph that is drawn. Okay, and then b, which has coordinates 16/9, and p is a point on f. So b is just a point on the function. Okay, now, first question. For what value of values of x is the log graph less than 0? Okay, now, what does that even mean? I always want to analyze the graph and understand what the question is saying. For what values of x is our graph? So remember, this part means y. Okay, so where is our graph under the x-axis? Okay, and what is that region? Let me highlight it. It's that point coming down. Right. Now, very important, we are dealing with less than or equal. So we know that the standard cut here, that'll be what? That'll be 1 and 0. Okay, now let's talk about that region. So that region is simply x is between 0 and 1. You do not include the 0. Why? Because the y-axis is the asymptote, right? Or it never touches that y-axis. There'll be a point where they even run parallel, but very, very close to each other. But it never, ever touches that. Alternatively, you could have said it's 0 and 1. Just like that. And then you get your 2 marks for that. Just write down the answer here. Okay, so we can clear the graph. Okay, moving along. Determine the value of P without the use of a calculator. Okay. Now, our graph is, so log base of P for 3 x is equals, and B has coordinates 16/9. Okay. So y is equal to this. All right. Now, let's see what we can do here. So we should be able to substitute because you have the coordinates of B, 16/9. And P. This is the x value, that's the y value. That's the substituting. So I'll say p is equal to log. So the base is 4/3, and then x is 16/9. Okay, now we're gonna get rid of the log. I'm sure you guys are pretty comfortable with getting rid of the log. We will say this is 4/3 to the power of p is equal to 16/9.
Right, Sepang.
You?
When you're done, Relebohile is asking you to repeat number 1.
Okay, all right, let me just finish this one up. Thank you. Okay, now once we have this, we just apply our algebraic skills. We know this can change to 4/3. Sorry, there's still a p here. Let me not forget that p. 4/3 only if we square it. Now, exponential rules, when bases are the same, we consider the exponents, meaning that p is equal to 2. Then you get your 3 marks for that one. Okay, perfect. Now, let's go back to 4.1. Okay, so for which value or values of x is the log graph less than 0? Okay, remember, this is telling us about y. Okay, or where is the graph under the x-axis? Right, that's what less than 0 means there. Okay, where is the graph under the x-axis? So I use the highlighter to just show you where the graph is under the x-axis, right? Or where it's equal to 0. And it's that region in green. Now, how do we represent that region? Remember, the graph doesn't ever touch the y-axis. Okay, but it will get very, very close to the y-axis. Okay, now how do we represent that green region? Right, we know it's very, very close to the y-axis at 0. So that's why we don't include 0, because it's very, very close to 0. And then because of the inclusion, that's why we have to say 1, because we know this point is 1. That is the standard cut. They didn't move the graph up or down, left and right. So it will intercept there at 1 and 0. Now that region is between 0 and 1, but inclusive of 1. Okay, then there is a statement from Chapel Omnisio. It's actually a question. 5.2 is it a problem? If I just say log of 4/3, 16/9, p is equal to 2. No, that's not a problem at all. Remember, with the memo, right, or your final exam on the memo, there are usually 3 or 4, sometimes even more solutions to one problem, right? So as long as it's mathematically correct, right, you should get all the marks. That one is perfectly fine, and you can go about it. You can go about it that way if you prefer that method. Not a problem at all. Okay, now 4.3, write down the equation of the inverse of f in the form y is equal to, all right? So let's check. Remember, our graph firstly is y is equal to log basis 4/3 and x. Now for inverse, what do? We always swap x and y. Wherever we see y, we put x and vice versa. So I'll simply say x is equal to log 4/3 and y. Okay, now that'll be easy for us to get rid of the log because we know this, excuse me, this will become the base. So we have y is equal to 4/3. This is our base, and our exponent is simply xd. And this is the inverse. Okay. Now,
Wait a second.
yes.
Let's check the chat box there.
Okay. I don't know what they're asking us to resend, because they're saying it's invalid. I don't think they're talking about, maybe if you can just text that person privately in the chat box. I don't think they're
Okay.
referring to what I'm doing here. Okay, Mukotwa, as they are rent paste, yes, you can unmute yourself, Mukotwa.
Sir, you were asked to repeat question 4.2.
4.2.
Yes.
Okay, sorry, I didn't see that. I'll quickly just go over it. Okay, so 4.2, they were saying, determine the value of P without the use of a calculator. Okay. Now, we have the function which is y is equal to log base 4 over 3x, right? And we have a point on that graph, which is the x value is 16 over 9 and the y value is just P. So all I did is I substituted them. So my y is just P and my x is 16 over 9. Okay, now all we're trying to do is get rid of the log, right? So the base of the log is going to be the base in the exponent, and P is going to be the exponent. Right? So the base comes here. The base comes here to be a base in our new exponent or our exponential equation. Now that we have 4 over 3 is to the power of P, this is still equal to 16 over 9. Right? Now, I know that 16 over 9, I can rewrite it as 4 over 3 only if I square it. Now check something. The bases are equal to each other. Because those bases are equal, exponential rules say if bases are the same, we can consider the exponent. Right? And in this case, because the bases are equal, then the exponents will be equal. Hence, we have P as equal to 2. Okay. Then moving along to 4.4. Write down the range of y is equal to, so the inverse. Right? Write down the range of the inverse. Okay. So I used to struggle so much with inverse, with the range and domain. I always swap the two around. Like whenever they ask for range, I give them the domain, right? Now, how do I remember? I had to then remember it. Now, I write range this way, right? Please don't write this in your book, but this is a way of remembering it. This is how I do it. Range. I write it how I say it, range. Then I know immediately that I'm dealing with the y values whenever I'm talking about range. Okay, then obviously if range deals with y, domain will deal with x. Okay, now the y values where our graph exists, in other words. Okay. I nearly made a big mistake. I nearly gave them this function, the inverse function, and that's not what they're asking. The question clearly says what? Write down the range of the inverse. Okay, and I think we found the inverse. Yes. The previous question says find the inverse. So the inverse is y is equal to 4 over 3 to the power of x. Okay, now what kind of a graph is that? That is an exponential graph. Okay, now just okay. So that is a graph with a standard cut at 1 and 0. So 0 and 1 rather. The graph is going to be increasing. Something like that. Okay. Now, what is the range of this? This was very important. The range of the inverse, not the graph that they had given you to start with. The y values where our graph exists. That would simply be y is greater than 0. Do not say equal to 0, because if you say equal to 0, then what you're saying is that it eventually touches the x-axis somewhere. And we know that it will not touch the x-axis in this case. Okay, and or alternatively, you could have said y is an element from 0 all the way to infinity. Infinity is never ever included. Why? Because we haven't found infinity, right? So if you say you found infinity, then somebody can just come and add 10 to your infinity. So the graph will still carry on. That's why we never include infinity. And we don't include 0 because the graph doesn't touch 0. Okay. Okay. 4.5. The function h of x is equal to 3 over 4 to the power of x is obtained after applying two reflections on f. Okay, write down the coordinates of b prime prime, the image of b on h. Okay, now let's see what we are doing there. So reflection. Okay, the graph that we had was 4 over 3. Reflections on f. Okay, I'm going to go back to f. That's the one that I started with. I want that equation so that I can see what happened to it. So the equation of f was simply log base 4 over 3. Log 4 over 3. All right. Now, if that's the case, they're saying this new h of x is obtained after applying 2. So after reflecting, right, f 2 times, after applying 2 reflections on f. Now the coordinates of b, the image of b on h. Okay, so let's see. So b had coordinates 2, 9 of 16 over 9, and positive 2. 16 over 9 and positive 2, like that. Now what we need to do is reflect it twice. Okay, now if you do your reflections twice, you will see that the image of B, right, there isn't a calculation for this one as it's 2 marks, right? You'll see that your new coordinates, or the coordinates of B, the image B prime prime, is going to have the coordinates -2 and 16 over 9 because of us reflecting it 2 times. Simple as that. That is how we get the image of B. Okay. Not seeing any questions in the chat. Good so far. Okay, then here's a new question. Now, let's see the graphs of f of x, which is a hyperbola, which is 2 over x plus 1 plus 4, and a parabola g are drawn below. Okay. Now see the turning point of G lies on the horizontal asymptote of F. So it is touching that asymptote. We're not even going to assume if it ever comes to that then we know that it is actually touching that asymptote, right? Not if, but G, okay? The graph of G passes through the origin. Okay, perfect. They gave us that as well. Then B, which has coordinates K and 14/3, is a point on F such that BC is parallel to the y-axis. Okay? Write down the domain of F. Is that a question?
Yes, there's a question there.
Okay. Okay, so they're asking, so why did we switch signs on the image? Okay. Now let's go back then. Now, remember with a reflection, right? What you're going to do is you're going to reflect where? On the x-axis, right? And you're also going to reflect on the y-axis. So you can reflect on the x-axis, and you're also going to reflect on, so remember whenever you have your Cartesian plane like this, then there's this line, dotted line. And this one we know as y is equal to x. Now, if you reflect, right, you can reflect on the x-axis, right? And remember what happens whenever you reflect something on the x-axis. So let's say, think of an arbitrary set of coordinates, 2 and -2. So if I reflect these on the x-axis, it means I'm reflecting, this is my axis, then this b is now going to be here, which is simply going to be 2 and +2. That's what's going to happen if you reflect on the x-axis. Notice what is happening to the sign. The sign was negative, suddenly it's positive. Because reflection across the x-axis will change your value, the value of your sign. Because look where you are now in the first quadrant. And what do you know about x and y? They have to be both positive. Okay, now let's look at, so we can call this b prime. Now let's look at b prime. If we reflected across, maybe let's look at the y-axis. So if we reflect across the y-axis so that it's now here, we're going to have -2 and +2. Why? Because we're in the second quadrant. And because we're in the second quadrant, what do we know about the x values there? The x values are negative in that quadrant. That is why we switch signs. Coming back to our question here. So I was just saying that B, which has coordinates K and 14/3, is a point on F such that BC is parallel to the x-axis. Okay, that's fine. Then the first question says, write down the domain of F. So remember, I dealt with domain and range. We know that range deals with the y values because of the way we write it, and then domain is going to deal with the x-axis, or the x values rather. So the x values where F exists. Okay. We know that it is not going to exist only where? At the asymptote, because it never ever touches that asymptote. Okay, so we can say x is an element of real numbers. Okay, but we need to add this note here, that disclaimer there, that restriction cannot be, what's that point? Let's check. It is -1. That is the vertical asymptote. That is the domain of F. Okay, now determine the x-intercept of F. Okay, there shouldn't be a problem at all. So to determine that x-intercept, we know we're simply going to say 0 is equal to 2 over, so it's x plus 1 and plus a 4d. Okay, then let's just solve. -4 is equal to 2 over x plus 1. Then let's cross multiply. So we know we're going to have minus 4x minus 4 equals to 2. So minus 4x is equal to positive 6. Then x is equal to minus 3 over 2. They only wanted the x one, so I don't have to substitute this back to find. Here's a minus. Nearly forgot that minus, and it's going to mess a lot of things up. So because of the minus in front, minus 3 over 2. We're only looking for the x value. I don't have to substitute it in. Okay. Now, calculate the value of k. Let's see. What do we know about k? So it is the x value when y is 14 over 3 on f. Okay, that shouldn't be a problem at all because we know our function y is equal to 2 over x plus 1 and plus 4. They gave us the y value, 14 over 3. This is equal to 2 over k plus 1 and plus the 4. I just substituted the y value. And it's just easy math from here. We will just take the 4 over to the other side. So I have 14 over 3 minus 4 is equal to 2 over k plus 1. Okay, then what we can do is we can just find what that is on our calculators. It's 4. So this gives you 2 over 3 is equal to 2 over k plus 1. Okay, I'm just going to carry here. I didn't give myself enough space there. I'm going to say 2k plus 2 is equal to 6 because I cross multiplied. Then 2k is equal to 4. K is equal to 2. Now, write down the coordinates of C. Let's go back to find C. So C, those are the coordinates of the turning point of G. Okay, now, do we know anything about G? No, we don't, but we know what this is. Okay, so that horizontal asymptote, that is going to be at positive 4, right? So we can easily tell what the coordinates of C are, right? So those are going to be, we found K to be 2. So the coordinates of C are going to be positive 2 and 4. Why is it 4? Because of the asymptote. That's how we quickly find those C coordinates. Okay, no questions so far. Now, 5.5, determine the equation of G in the form y is equal to a into x plus p squared plus q. So the turning point form, that shouldn't be too much of a problem. Let's see what we can do. So because we have the coordinates of the turning point, which is what we just found, I'm going to say this is x minus 24. So this will be minus 2 squared, and then plus 4. Okay, now I have a problem because I have a which I don't know. Okay, let's see if there's a point that they give us on the graph. There is a point, right? So in case you're saying we're assuming that it touches the, we're not assuming because they did say that it passes through the origin. So we can take 0 and 0. So 0 is equal to a into 0 minus 2 squared plus 4. Then we know our a, so this is going to be minus 2 squared, which will give you 4. Take the 4 over to the other side. Our a is going to be minus 1 if you divide both sides by the 4. Okay, now we're on the right track because y is equal to minus 1 into x minus 2 all squared plus a 4. Okay, no questions so far. 5.6. For which value or values of x will f of x over g of x be less than or equal to 0? Okay, so I'm going to plead with you now. Whenever you get such a question, please do not try to do it algebraically. Try to analyze from the graph, right? Because imagine if you had a log graph there, it will be quite difficult for you to find f of x over g of x, right? Now let's try to use analysis. They're saying f of x over g of x is less than or equal to 0. I need everybody to pay extra attention. What does less than 0 mean? Negative. Okay, now how can we get a negative from a fraction? It's either f of x is positive and g of x is negative. Because positive divided by negative will give us that negative, or negative over positive. So the first case, sorry, in the right one. So the first case, case 1, is when our f of x is positive and our g of x is negative. Second case, vice versa, when f of x is negative and g of x is positive. Now let's look for that. Yeah, just gonna copy down that question. F of x over g of x. So f of x over g of x is less than or equal to 0. I'm just writing it down here so that I can check and highlight where I need to. Remember our cases. The first case, that's positive on top, negative down there. And then alternatively, that's negative and positive down there. Okay. Let's deal with the first case. Where is f of x on top of g of x? Let me use my highlighter to show you guys. So in that interval there, or that highlighted section, that's where f of x is on top. That's the first case. Now, how do I represent that case? Okay. I'm hoping I'm not making any mistakes now. Everything still looks fine. So where else is, maybe let me use a different color to see where we have f of x being negative and g of x being positive. Okay. Now, notice something. Let me start with the positivity actually. So the graphs, so this graph is positive. That's fine. Now, f of g of x, sorry, the parabola is also positive in this interval or that because it's on top of the x-axis. Now, if I have a case like that, that's not going to work because both of them are positive. So I need to think about another case. So can you see this part here? That will work for me because I have this, which is positive, and this part, which is negative. I need you guys to understand that part. So in between this here, f of x is positive and g of x is negative, which is a range that I'm to be dealing with. That makes sense because when one is positive and another one is negative, that's exactly what I want. How do I then represent that? That'll be x is between, I know the x value here, it's -1. And 0, less than 0. That is talking about this interval in here. Okay, I know it's a little bit messy, but let me just erase it so that you guys can see. Just going to highlight that interval. So positive. Here, f of x is positive, and f of x is negative here. That works. Okay. is there any other place where we have this kind of a scenario? Yes, there is. Check here. Negative. Okay. Let me just do this. Take it up a little bit. So if this dotted line is parallel to the y-axis at that point, then I have this kind. So this is positive B. So that also works. Okay. Now, don't I know this? I know what that is. Okay. And what is that? I know that point is 4. Remember, we have the equation of g of x, so we can find the x value. Now, how do we represent that region? We'll simply say x is greater than 0. Okay, I'm not including, even though they use the inclusion. Why am I not including? Is there anyone who knows why I'm not including? If you know, you can just type in the chat. I'm going to leave it out. Let me just do it. Why am I not doing it like that? Okay. There are no answers in the chat, so I'm assuming you guys don't know. But the reason I'm not including it is because if I say it's equal to 0, then it's very dangerous, because look at it. The fraction f of x over g of x, now g of x becomes 0, and we can't divide by 0. That is why we say greater, but greater than 4. Greater than 4, not including that 4. We can't put this. Because if we include it, it's going to be undefined at that point. Okay. Now we're done with f of x being positive and g of x being negative. Now we need the other way around, where f is negative and g is positive. Okay. Now g is positive in this interval. So top of the x-axis. Okay. And in that same interval, is there a place where f of x is negative? I'm just trying to double check that I'm not missing anything. With this part here, that's positive. It's not in that range really. Everything looks fine. Okay, so here are our answers. X must lie between -1 and 0, or x must be greater than 4. Hoping that makes sense. No questions so far? Okay, so we can move on. Now they say use the graphs of f and g to determine the number of real roots of 2 over x minus 5 is equal to minus x minus. Yes, yes, I can.
Something just, sorry, popped up at me. Do you mind going back to that diagram?
Okay, no problem. I can go back.
Actually, you didn't write down. Okay, oh, sorry, it's behind my little chat thing. So you're saying f of x over g of x less than 0, right?
Yes.
Which means when one is positive and and the other one is negative.
Yes.
So, because you've got there x between 0 and -1, and x bigger than 4. It's because the domain of g is negative infinity to positive infinity, there should be a point where G crosses the x-intercept of f.
There should be a point.
Yeah, where G will have an x, so look at the x-intercept of f, right?
Yes. Yeah.
Where f is positive. Because the domain of G is negative infinity to positive infinity, there will be a point where G is negative and f is positive on the left-hand side of that x-intercept.
Okay, so this is case 2, where G is positive. Okay, so G is going to carry on in the direction.
Where G is negative and f is positive.
G is negative and f is positive.
Yes.
Okay, I'm with you. Sorry. Yeah, because it's not drawn. Okay, let me just draw it. Thank you so much. I wasn't seeing it. I can see what you're saying very well now. Okay,
Yeah.
I'm just going to then extend the drawing so that I can show the intersection of the two. So thank you so much for that one, Ernest. Just need to extend. So let's say G opens up that way, and then F is going to keep coming down, and then somewhere, somehow, they will touch each other eventually. Okay, now, because they will end up touching each other, so now we have this case. So from this part going to the left-hand side, G is actually positive in this range, or in that interval, going to the left-hand side. Going to the left-hand side, that is positivity. But what do we know about G? So F is positive there, G is negative here. And we can find that, I think we found it. That was the X value, which we found to be minus 3/2. This was 5.2. And that is another perfect case. I'm just going to use my highlighters there to show it. My drawing is not the best, but it's the first case where we have the green graph here. It's positive. And then I'll use red to show the other one. So this part here, that's negative. And the last one is where X is less than 3/2. Okay, but this time we can include it because the 0 can be on top. It's not down where it gives us an undefined. So we will have 3 solutions: number 1, number 2, and number 3. Thank you so much for that one, Ernest. I didn't see that I can actually extend the drawing to see the left-hand side.
No problem.
Thank you. Okay. 5.7. Are there questions in the chat? Okay, so some people are complaining about the network, but this is recorded. We will send the recording links here. So 5.7, use the graphs of F and G to determine the number of the real root of 2/x minus 5 is equal to minus 3 is equal to minus into x minus 3 all squared minus 5. Give reasons for your answer. Okay, so I'm going to try and break this down for myself. Let me just deal with this. Okay, so if I have 2/x minus 5, okay, I'm going to try and relate it to the hyperbola. Okay, 2/x plus 1 plus 4. 2/x plus 1 plus 4. Okay, so I'm going to try and relate the two. But now what I'm going to simply say is what's happening to F? So for it was originally this. Now I have 2/x minus 5. It means that F was what? It was shifted 1 unit way, right, and what? And 9 units down. Okay, let's look at the other graph. So now I have minus into x minus 3 squared minus 5. I'm going to compare it to what I have, which is squared plus 4. It's going to go up to double check. It's perfect. Okay, now let's talk about G. What's happening to G? So G is shifted away 1 unit, right? And 9 down. Okay, now as you can see, 1 unit right, 1 unit right. 9 units down, 9 units down. So we did the same thing. We shifted the whole thing down. Okay. Now, just going to make a note there. So the shift of both graphs I'll say took place relative to each other. I'm just explaining that it's 1 unit down, 1 unit to the right, and 9 down on both graphs. Okay. Okay. Now, if that's the case, right? Let's see what's going to happen. I'm just going to shift so that I can see my graphs. Okay. So we're just taking this whole set and moving everything down, right, by 9 units and what? And 1 unit to the right. Let's go back and try to answer our questions. Now, there will only be 1 point of intersection, right? Which point am I even talking about? I'm going to go back to the graph so you can visualize it again. I'm going to try and clean it up. The graphs were intersecting somewhere at this point here because F is going to come there, and so F is going to come there, and G is also going to come there. Now, what we're doing is we are shifting this way to the right, and we're also shifting it down. Okay. Now, because we're shifting it 1 unit to the right and 9 units down, the only point of intersection that we're going to have is still this one, because the rotation, right, not the rotation, but the shifting of the graph, right, happened on both of the graphs. So 9 units to the right, 1 unit to the right, and 9 units down. This point, that's what happened. Because it's to the left of this asymptote, even when we shifted 1 unit to the right, it's still going to be less than 0. 9 units down is probably going to keep it somewhere down here if we had extended our axis like that. So the only point of intersection would still be this one. Right? And that means we have only 1 railroad or 1 point of intersection, because that's when we equate the 2 graphs to each other. Okay. I think there's a question in the chat. Okay. Somebody is asking me to repeat. I don't know if they got this right. But what I'm going to do is I'm just going to explain how we got about the shifting. So the first thing that I did is I looked at the hyperbola. Right. So this is the one that they gave me, 2 over x minus 5. And the original one that I had was 2 over x plus 1 plus 4. So I'm trying to see what happened. So I had a plus 1. Now I no longer have a plus 1 there. So what happened? We shifted it 1 unit way to the right. Okay? And whenever we shift 1 unit to the right, what do? We simply say minus. So it was a minus there. That's how we get a 0 there. Then we had a plus 4 to start with. Suddenly, what do we have? We have a minus 5. What did we do? We subtracted a 9. Okay, that's how we got 1 unit to the right, 1 unit to the right, and 9 units down. Then I looked at my parabola. The one they gave me was minus into x minus 3 whole squared minus 5. And the original one that I had was minus 1 into x minus 2 squared plus 4. So what happened? I had a minus 2 and a minus 3. So what happened? It means that I shifted it 1 unit to the right as well. Minus 2 minus 1 will give me minus 3. Then I had a positive 4. Suddenly I have a minus 5. It means that I also subtracted 9 there. Okay, so the shifting of graphs happened for both graphs. So the same thing happened for both of the graphs. So all we did is we used this whole set of graphs that we have. It was able to just grab them and move them around. I was going to show you that we're actually taking them as they are, not one by one, but the whole set of graphs there. We're shifting them 1 unit to the right. After shifting them 1 unit to the right, we're shifting them 9 units downwards. Right? We can do that because we know that this is applied to both graphs. Okay. Now, we know that where they touch, I'm just going to erase this. Where these graphs touch somewhere here, okay, let me just extend this a little bit. So this parabola is going to come down, eventually past the asymptote. Remember, it will pass through the asymptote. It's a parabola, it doesn't have any asymptotes there. But the hyperbola will not touch the asymptote, so it will keep coming closer and closer, and then finally they will touch where? Before that asymptote. And we know this is minus 1. Okay. Because this is to the left, even if we shifted it to the right by 1 unit, it will still be before, I'm just going to extend that a little bit. It will still be before 0, meaning that it's going to be somewhere there. Okay, that's the point of intersection of the two graphs. Now, do they touch each other anywhere else? No, they don't. And because that's the case, we have our answer. So 1 point of intersection or 1 real root, just by doing it that way. Okay. I'm not seeing any questions in the chat. Then I have prepared a few questions for us to go over together. Let me just share my PowerPoint. We can just select the correct answer and then just type it in the chat. Let me share my screen. Ernest, please confirm if you guys can see the screen that I'm sharing.
I can say it.
Yes, we can.
Okay. All right. Thank you. All right, guys. I have a few questions. Well, 2 questions for us to do. You are more than welcome to then just start. As soon as you have an answer, please type it in the chat. So the first question, find the inverse of f of x is equal to x squared minus 1. Okay. So you're probably going to need pen and paper to actually write it and do the calculation. Okay, I'll give you just a minute for that one. Okay, if you have an answer, please type it in the chat.
Yes.
Okay, there's already an answer.
It's
Please
clear.
remember to keep yourselves muted. Okay, answers are coming in the chat. Thank you. Forty-five more seconds if you are working it out. Thirty seconds left. Let me go to the next question. Fifteen seconds left. Please type quickly before we move on. Okay, time is up for that one. Let's quickly check the chat before we move on. Okay. Okay, I'm seeing a lot of B's. And then there's D as well. Okay, but it looks like the B's are dominating. I'm not seeing. Okay, there's an A as well. Okay. All right. So
On TikTok, I've got a variety. It's upon there's some C's, some D's.
Okay.
Someone posted an E, but I think they fixed their mistake. They said D.
Okay. All right. Good. Okay, we're going to go over it together. Let's see which one is the correct answer. Okay, let me just try to annotate. Okay, so to find the inverse, so firstly, I'm going to write it out for myself. I know this is, let me change it. Y is equal to x squared minus 1. Now, for the inverse, what do we need to do? We need to swap. So x is equal to y squared minus 1. Okay, then we need to solve for y. I'll say x. Just erase these. I'll say y is equal to y squared is equal to x minus 1. Then y is equal to the square root of x minus 1. Okay, I see why some people picked D because I did not, that was my mistake. I did not include plus or minus, right? I did not see that one, but wait, hang on. Am I on the right track? Hang on, let me just fix this real quick. Could be making a silly mistake. I'm just gonna go back up. Hang on. Here we go. So we've swapped. So let's now work it out. I'm gonna say this is x plus 1 is equal to y squared. I don't want to miss any steps because then I make mistakes. And when it's like that, I'm going to try and find the square root. So I know that y is equals to plus or minus the square root of x plus 1. Okay, so the only thing that I forgot was I forgot the -1, right? So what I will do is I'll be fair. If you picked B, I'll give you a mark for that one. You got it? And if you pick none of the above, only if you are saying it needs to be plus or minus, then you get the mark. But we see why it's not A and why it's not C. Those two are clearly out. For D, you'll get it only if it's because you're punishing me for the plus or minus, which is very important. If that's the case, then you get all the marks for that one. Okay. Then there's another one. Okay, let me try to here. Okay. Now here's another question. How can we restrict the range of the inverse of f of x is equal to x squared minus 1 so that it becomes a function? Okay. So if you want to write it out, please do so. Give you 2 minutes for that one. Please read the question carefully. Make sure you understand it. Okay, answers are coming in the chat. I'm seeing a lot of B's. There's an A as well. Okay. Just a minute, and we'll look at the solutions.
I've got 2 C's on TikTok.
Okay, perfect. 30 more seconds and then we are doing this together. If you're working it out, please try to be a little bit faster. Twenty seconds left. Fifteen seconds. Five seconds left. Please type in your answer now. Okay. Perfect. Thank you guys. Let me stop. Okay. I'm not gonna stop sharing my screen. Instead, I'm gonna look at the answer. I'm gonna write it there on the screen for you guys. So I'm getting a lot of B's. Then there's an A as well that I saw here. Okay, Ernest, on TikTok, you said we are having a lot of C's.
The last time there was C's, but now I've got, after I said that, then I just got a string of B's.
Okay, all right. Okay, let's look at it. How can we restrict the range? Okay, very important. This is what needs to be restricted. The range of what? Of the inverse of f. Okay, so remember what we're going to do is let's look at f of x first. We know it's a parabola that something like that. No. Oh, minus one. Sorry, there we go. Minus one, because it was shifted 1 unit down, not plus one. So that point there is minus one. Now, the inverse of this function, what would it look like? So the minus one here, then our graph is going to look like that. Okay, so we want it to now be a function, okay? But we need to do that by restricting the range. Okay, remember I said how I write range so that I remember it is I will say range with a y there. Now it means I'm dealing with the y values. So this is going to be out. This is also going to be out. Okay. Now, if I restrict it this way, if I said y is greater or equal to 0, which portion of the graph am I talking about? I'm talking about this part where it's positive because it's greater than 0, right? Now imagine that this is no longer there because we're restricting it that way. Now we're going to have a one-to-one, which is a function. Okay, or the other way around. If we only restricted this part and only focused on the bottom part, doesn't that become a 1:1? It does become a 1:1. And this is also a function. So this is the O part where we have y is less than or equal to 0. So the thing is that this question was asking how can we restrict the range of that inverse so that this is a function. We're not restricting the domain of the function. So the correct answer will be B. A lot of people got that one right. Awesome, awesome, guys. See, a lot of people are actually paying attention and they understand how to go about functions. Okay, so I'm going to go back to the problems that we were dealing with because we have about 7 minutes left. It is now a Q&A session. So if there are any questions, let me just go back. So please ask your questions in the chat. And then we will help you to unmute so that we can look at some of the questions that you might have. I think that's someone. Chantal, you can go ahead. I don't know if you have a question.
It's over now. We can focus on our future together.
Hi, Tsepa.
Yes, dear, can go ahead.
Happy alumnus. Here's a question there. It's very interesting.
Okay, I didn't see. Let me just quickly go back to the chat.
I guess he's saying they did so well. They're asking if they're getting extra data.
Oh, I see. I was trying to understand that.
Is Tapelo wanting extra?
I think Tapelo is wanting extra
Yes,
because
it
he's
seems
been
like.
giving those correct answers. Eh?
Let's see. Maybe we should consider it. We'll talk to our bosses, Tapa, and see if
Yeah,
our
100%.
will allow us to have an extra
I
prize.
think, yeah,
We'll do
I think maybe
one for TikTok and one for the guys on Zoom.
100%. I'm with you, Ernest. I think what we can do is we can prepare a nice quiz for them, and then we'll see. We'll have one for maths and one for science that covers everything that we've done so far, and then check them. Isn't that fair?
No, I'm with you. I agree strongly on that one.
Okay, then Tato Matlala, can you repeat the last question? Okay, no problem. I'll go to the very last question. Okay, so this was the last question. Okay, 5.7. Use the graphs of f and g to determine the number of real roots of those two graphs being equal to each other. Okay. Now, what I tried doing is, so the first thing that I did is I extracted that part. This is the hyperbola, right? I extracted it, I wrote down the left there, right? And then I compared it to the original parabola that they gave me, right? And that parabola that they gave me was +1 here. Okay, then with a +4. Now what I did is I'm comparing these two graphs. What happened? Let's look at the x values first. What's happening to the x, right? We had a +1, suddenly we just have x +0, if you may. What happened? We subtracted 1. Okay, and we know for x, that means that is a shift to the right. And because it was 1, now it's 0, it's 1 unit to the right. That's the shift. Okay, now let's look at the y values. Originally we had, to start with, we had 4. Now we have -5. How did we go from 4 to -5? We needed to subtract 9. And that's just the difference from between 4 and -5. Right, so I got the shift for the hyperbola. Okay, we just write hype there. That's what happened to the hyperbola. Now I'm talking about the parabola or the quadratic graph, quadratic function. This is the one that they gave me, minus into x minus 3 all squared minus 5. The original one that I had was -1 x minus 2 all squared plus a 4. So I'm going to do the same thing. I'm going to compare the x and the y's. I had -2, now I have -3. What happened? I've shifted it. Way to the right. Okay, by how many units? By 1 unit. Hence I have this, 1 unit to the right. Now let's look at the y's. -4 and -5 as well. I've shifted it by how many units down? 9 units down, because that's the difference between 4 and -5. Okay. Now, this is very important. 1 unit right, 9 down. For the hyperbola, 1 unit right and 9 down for the parabola or the quadratic. Surely that means something. Because we're only dealing with the parabola and the quadratic. That's what they gave us with the scholar. We only have a parabola and a hyperbola here. If the parabola is being shifted to the right and 9 units down, and the same thing, right, is being done to the hyperbola, it means that we are actually shifting everything as it is, right? 1 unit to the right and 9 units down. Okay. Now we need to check, where were our graphs touching each other? They were only touching each other at this point here. Okay. Now let's shift. So 1 unit to the right, it's going to land at that point somewhere here, but then 9 units down. So it's probably going to be at this particular point because of the 9 units downwards. Okay. Now, is there any other point of intersection on our graphs? There isn't. Now we need to think, after shifting, after applying that shift, 1 unit to the right, 9 units down, does that affect the number of times these graphs are going to touch each other? That doesn't. We know that that point of intersection that we had is still going to be there, but it's just going to be at a different point. 1 unit to the right, 9 units downwards. Right? With that being said, then we can answer. Right? So I just put a note there to say, well, the shift was on the 2 graphs, right? Or it took a place relative to each other. So whatever we did on f of x, we also did it on g of x. Right? And if that's the case, we're only going to have 1 point of intersection. Because whatever we did to g of x is what we did to f of x.
Would it be a stretch to try and do that on a GeoGebra or Desmos?
I can try to do that.
If you give me the functions, maybe go to the expression.
No problem.
Got it open and try and see if we can quickly represent it and see if it will help. Then at least we can visualize it.
Do you want the original ones or the shifts?
Okay, go back down to the shifts. Let me see something.
Okay, no problem. So let me just erase a few things there so you can see. I think you want this part here.
Okay, so should I? Oh,
Yes,
what
I can stop sharing.
I can do. Oh, don't stop sharing yet. I don't have those. So we can maybe do the originals and then do the shift on the originals to see how many roots did we have initially and then how many roots after the fact.
Okay, perfect.
I don't know if that would help. So
no, that will help. That will help.
Okay.
Definitely.
What give me?
So here are the originals. So here's one, and then here is the other one.
2 over x minus 1. Sorry, 2 over x plus 1 plus 4. And then, okay, so let me do this. Let me try this. Just guys, please be patient. We're going to try something here. X shift. The shifts, do they ever go above 10?
Usually no, they don't.
Okay, and then let's do a Y shift. They don't go above 10. Okay, then the original function of the hyperbola, we've
2
got
over x plus 1,
2 over
2 over x plus 1,
x plus 1. I'm going to then say plus x shift. And then that's plus 4.
yes, it's plus 1.
Plus y shift. Okay, and then our other function is going to be,
You want the original parabola.
yeah, the original parabola.
Minus
The red
1
one.
into x, minus
Okay.
1 into x minus 2,
Into x minus 2 plus x
all
shift.
squared, and then plus 4.
Okay, all squared plus 4 plus y shift. Okay, let me share my screen. I'll have to do this for both Zoom and TikTok.
Yes, yes,
Just
please.
give me a second to try and figure out how I'm going to do this. Okay, I'm gonna just double check one at a time. Just confirm if you can see it on Zoom.
I can see it on Zoom.
Okay, and then I'm gonna just add it on TikTok as well. Apologies to the guys on TikTok if the screen's gone blank. I'm quickly just adding my screen share. Capture, give me 2 seconds, I'm almost there. Okay. Whoever on our team that's on TikTok, please just confirm that you can see what I'm sharing on TikTok. Okay. I don't know, just Tapang is now on the call on Zoom.
Just
Okay, either way. Okay, I think it's there. I think it should be visible. If anyone on the TikTok, guys, if you're watching and you can see, you should see 2 functions, a red hyperbola and a blue parabola. If you see those 2 functions, please just put a thumbs up in the chat or put a yay, we can see it. Okay, so I tried to do this, Tapang, where I've mapped the 2 functions. I hope they look like the functions you had in the question.
yes, yes, they do.
Okay. So now, if I shift them left and right, there we go. They do move. So how many units do they shift left or right?
They move 1 unit to the right.
So 1 unit to the right, like that.
Mm-hmm.
And then how many units down or up?
9 units down.
9 units down. Looks like that. Let me zoom out and see what it looks like there. So I don't know if that's helpful to the question that you were doing. I can't remember the answer that you gave. Is this an accurate representation? But at least then
100%. Can you just shift it up a little bit so that we can see that point of intersection?
Oh, that one there. I'm with you. Sorry.
Yes. Yeah,
This
no
one
problem.
there.
Yes.
That's what you're looking for.
Yes, that's what I was looking for. And that explains it very well because the shift, both graphs shifted 1 unit to the right. We shifted them as a unit and they both shifted 9 units downwards. Right? Now, where else are they touching each other? There's no other point of intersection except A.
100%. And even if you move them in any other direction, if you look at, I'm going to zoom in there, that point A is our point of intersection, if it's visible. If I move them up or down, that point of intersection remains the only point of intersection As I move them around, I can zoom out again to make it a bit more visible. As I move the functions left and right, that point of intersection remains. If I move them up and down, that point of intersection remains. So at least we can even go visualize this thing using this awesome tool called GeoGebra. That you can actually use this stuff to make functions a lot more cool, a lot more visible for yourselves. Yeah, there we go. Okay, fantastic. They were saying it's visible on TikTok as well. Thank you so much, Tapan. Appreciate it.
Thank you so much, Ernest, for that awesome demonstration. I think that makes it even more clear. I think we are covered for today. I'm not seeing any other questions. Tato, I'm hoping that demonstration makes sense to you. Yeah, if there are any other questions, please do post them in the chat in these remaining 2 minutes so we can quickly help you out. If not, I think we are done for today. Then we are having another session tomorrow, which is going to be. Ernest, do you have it open on your side? Okay, I think I have it open.
Tomorrow's session is going to be
organic molecules
on TikTok just now. Tomorrow's session is going to be organic chemistry.
Organic molecules, yeah.
Quickly go to TikTok and then I just posted it now on our page. So especially for the guys on TikTok, if they want to see, there we go. I just posted it now. If I can scroll forward, there we go. Let me just pause it. Yeah. So we've got, today was functions. We've got organic chemistry tomorrow on Tuesday. Wednesday, we've got trigonometry, and then we're finishing off this week with projectile motion. It's going to be an awesome week, guys. Please make sure you join. Make sure the guys who you know should be in here, send them messages. Guys, let's join. Share the link with everyone. Let's make sure we get as many guys passing. We need to make sure you guys, class of 2024 needs to be the main class. We need you guys to be doing really well this year. We want to see distinctions coming out of this class. So yeah, please make sure you guys attend all the sessions. There is a hand. I see Tsapang on Zoom.
Hello. So data here, is it for today only?
Yeah, so the guys on the sponsored program, if you receive data today and you attended today, and if you attend for the session, don't just come and leave, then we will send you again data tomorrow for tomorrow's session. If you attend the session.
So does this one expire or will it still be available tomorrow?
It will expire probably maybe at midnight, but then we'll get you more data tomorrow to join the session.
Okay.
Okay, cool. All right, I think that's our session, Sapang. I don't know if
there's a last question from Tapelo Mnisi. Maybe you can just go ahead and then we'll end there.
Okay, no problem.
Tapelo, you can go ahead. Can unmute yourself and go ahead. Tapelo Mnisi, you can go ahead. Let me help them unmute. Are they still in the meeting? They've gotten disconnected.
I wanted to ask something, sir.
Yes, please go ahead, Tapelo.
I wanted to ask, when are we going to get the quiz? Because I heard you talking about the quiz for the extra data.
Oh, okay. Ernest, when do you think would be a perfect time to do a quiz? Should we have a weekly one or a one every 2 weeks? Or is it something that we'll discuss and then we'll tell them?
I think let's discuss and then we'll share it tomorrow.
Okay.
We'll share tomorrow's lesson, Tapelo. We're having a science lesson tomorrow, doing organic chemistry. And then in tomorrow's session, we'll tell you guys how it's going to work. We have to go sit with the team and see what's feasible. But we'll have some kind of quiz that we can put together for some extra data.
And then the ones who are not doing science, we will tell them in the math session.
Yeah.
Okay, thank you, sir.
Awesome.
Thanks. All right, guys, thank you so much for today. Sorry, someone's asking in the TikTok chat, where can I get the pamphlet you're using? The one, so what I was sharing on my screen, go to our page. It's a video we just uploaded now in the last few minutes. That shows us the upcoming lessons. It's just a video I put up. So if you go to our page, that's where I got it here. On our TikTok page, literally underneath our pinned posts, you'll see this one I just posted right now. It says join us every Monday to Thursday, 6 p.m. to 8 p.m. on TikTok Live. I know you guys were asking last week, when are the sessions coming? What sections can we prepare? So at least here I've posted the sessions for the week coming up. You can go see it on our page. Then another one says, guys, those who are struggling with electric circuits on physical sciences, kindly inbox me now. Don't worry about inboxing Muvumbi. Muvumbi, we're gonna be having electric circuits coming up pretty soon as well. But if you have something on there, do what you have to do. But we're gonna be having, so remember for us, we're covering every single section, guys, leading up to prelim. So we started last week and we're going to cover every topic that you need to do for your thing. So every week we're covering the topics as they come. We're going to end up with, I'm sure, 1 week of revision. So yeah, Muvumbi, go for it, man. If you're an educator and you're doing great things, shout out to you. Do what you have to do, my brother. We really appreciate it. Let's make sure we help these learners pass. Shout out to you. And then on our side, we're going to be doing electric circuits as well. Sometime in the schedule, we'll post the full schedule as they come. For now, I'm going to post just the upcoming week. And then we're going to keep it going, guys. Awesome. Thank you so much, guys. Hope you guys have an awesome rest of your evening. Tsapang, are you covered on your side?
I'm covered on my side. Thank you so much, Ernest. And then you can just lead us out with your awesome intro. Awesome outro.
Okay, Ernest,
No.
we've got projectile motion on Thursday, and had you not already covered it last week?
It's work energy and power. Yeah, it's work energy and power.
Apologies.
Yes.
I'll repost that one. Thank you for that, for picking that one up now. I'll repost the correct one. So it's work energy and power on Thursday. That's a very good one. Okay, I'll repost it. I'll take the video down and post the correct one. Thank you for that.
Thank you.
Thanks. Guys, let's Tsapang's big smile take us away. Thanks, everyone. Thank you very much for joining, guys. We have a lesson tomorrow, physics, organic chemistry. See you guys tomorrow. Cheers.